Well, 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 we are back at it again. Today we're going to understand the converse of the Pythagorean theorem. If you take a look at example 1, what it's telling you is something you already know, that a squared plus b squared equals c squared. You're going to construct a logical argument to show that ABC is a right triangle. In order to do that, basically what you're doing is you have to show that a squared plus b squared in fact does equal c squared. We're going to just briefly touch on the vocabulary here, the converse of the Pythagorean theorem. So put a star here, that's yellow, that is a vocab term you're going to need to remember. You guys are well versed in Pythag already, so we're going to jump right on down to the triad. The triad says you have a triangle that has side lengths of 4 inches, 5 inches, and 7 inches. Is the triangle a right triangle? You are basically answering yes or no, however you have to back it up with mathematical facts. We know that A is going to equal 4, B is going to equal 5, and C equals 7 because 7 is our longest side. So 4 and 5 are interchangeable, but the longest side must be in that place where C is located. 4 squared is 16, 5 squared is 25, and 7 squared is 49. The question is, does 16 plus 25 equal 49? 16 plus 25. Oops, let me turn that on. 16 plus 25, what does that equal? Well, it equals 41. So the answer is a squared plus b squared equal to c squared? You would say no. Is the triangle a right triangle? The answer is no. If it did equal c squared, then you would say yes, it is a right triangle. However, because 16 plus 25 really equals 41, this is not equal to 49. It is not a right triangle. So it says, explain the proof of the converse of the Pythagorean theorem in your own words. This simply means that a squared plus b squared must equal c squared in order to prove the triangle is a right triangle. On to example number 2. Again, we are sticking with Pythag, okay? The question is triangle XYZ a right triangle? Now we're applying this theorem, okay? So they're showing you that a squared plus b squared in fact does equal 625, so that XYZ is a right triangle. Okay? Here is an example with decimals, but showing you that it is not a right triangle. Now we're going to go down to the triad. A triangle has a side length of 10 feet, the square root of 205 feet, the square root of 105 feet. Is this a right triangle? Explain. So the first issue that you have is if you know your numbers really well and you can do the square root in your head, which I doubt it, no offense, you don't know which one's A, B, and C, okay? So I'm going to use my calculator to do second function square root 205, okay? That's about 14.3, okay? About 14.3. Okay, then the square root of 105 is about 10.2. Okay, that means now I know that this is 10 is going to be A, the square root of 105 is going to be my B, and C is going to equal the square root of 205. Okay, so now they're asking us to use this converse of the Pythagorean theorem to identify if this is a right triangle or not. So a squared plus the square root of 105 squared, does that equal the square root of 205 squared? Well, what happens if I take the square root of 105 and I square it? So in my calculator, I still have the square root of 105. Watch what happens when I square it. Equals. All I'm doing is removing this square root sign when I square it. So my problem's going to look like this. 100 plus 105. Does that equal 205? Okay, because when you square the square root, you're just undoing those two things. The answer is 205 equals 205. You would say, is this a right triangle? Yes. This is a right triangle because a squared equals b squared. I'm sorry, not a squared equals b squared. A squared plus b squared equals c squared. But you have the math to show for it, okay? So you can't just write these words and not back it up with mathematical facts, okay? Down to example number 3. It says, Ray drew the isosceles triangle LMN and the segment LP. How can Ray tell whether the segment drawn is the height of the triangle? The converse of the Pythagorean theorem, use the converse of the Pythagorean theorem to determine whether LPN is a right triangle or not. So they did a squared plus b squared, does it equal c squared, right? And found that segment LP is not the correct height for LMN. So this one right here. All right, so now let's go ahead down to the try it. A triangle is inside a trapezoid. Is the triangle a right triangle? Explain. They gave you all your measurements, so now we have to say yes or no. This is going to be A. I always label. This is going to be B, and this is our C. So 15 squared plus 17 squared equals the square root of 514 squared. 15 squared, I don't want to do that in my head, is 225. 17 squared is 289. Does that equal 514? So 289 plus 225, and it is 514 equals 514. So you would say, yes, the triangle inside a trapezoid, stealing words from the question, guys, is a right triangle because a squared plus b squared does in fact equal c squared. Period. That is lesson 7-2.